So when we want to rationalize the denominator for 1 over square root of 2, we can just multiply the bottom by square root of 2 and do the same thing on the top. And we will end up with square root of 2 over just a 2. And this is it. And in fact, if you want to see why we do this, I do have another video for that. You guys can go ahead and check that out. The link will be in the description. But the question right now is that, what if we have 1 over cube root of 2? Can we just do the same thing? Multiply this by the cube root of 2 and do the same thing on the top. And do we still end up with the cube root of 2 over 2? In fact, this is not correct. And in fact, this is also a very common mistake, especially when you first learn about this kind of things. Why is this wrong though? Well, we just have to be careful with it. Because if you take a look right here, when we have the cube root of 2 times the cube root of 2, what do we really get? We keep the cube root, we multiply the insides, 2 times 2, we get 4. And the cube root of 4 is still an irrational number. So we cannot do anything with that. So how do we solve this? In order to really simplify it, we have to first know the perfect cubes and of course the corresponding cube roots. So let me write this down right here for you guys. First, you should know that the cube root of 1 is equal to 1. Yes, I know this right here, it will not do us any good, but it's a good start. Next, we need to know the cube root of 8 is equal to 2. Why? Because if you take 2 times 2 times 2, we get 8. Therefore, cube root of 8 is equal to 2. Now, what if I want to get to 3? Then it will be the cube root of what? It will just be 3 times 3 times 3, which is 27. How about the next one? Oh, I heard you say 64. Yes. That will give you 4. How about let's do one more? Cube root of what will give us 5? 125? Yes. And then so on, so on, so on. So this right here are just some of the perfect cubes. Of course, the first one, we never need to use it. So let's go back to here. I will show you guys 2 ways to think about it. The first way is when you look at 1 over the cube root of 2. You can think about it like, we have 2 inside already. 2 times what will produce one of these numbers? And go with a smaller one, like this right here. 2 times 4 will give us 8. Therefore, we shall multiply the bottom by the cube root of 4 and do the same thing on the top. As you can see, 2 times 4 is 8. In the cube root, we'll just end up with a nice number 2. And for the top is the cube root of 4. And this is how you correctly rationalize the denominator when we have a cube root number on the bottom. But there's another way to think about it. If you have 1 over the cube root of 2, which is the same as 2 to the first power, well, we have the first power already. In order to get out of the cube root, we have to have the third power. Let's just go ahead and multiply by the cube root of 2. We only have power 1. We need 2 more. So 2 to the second power. And do the same thing on the top. As you can see, this times that is 2 to the third power. And then when you take the cube root for that, they cancel out precisely. And on the top, you just have cube root of 2 squared, which is 4, over the bottom is just a nice number 2. So one way or the other, one way or the other for you to think about it. Now let's do a few more examples. For the first one, we have 6 over the cube root of 5, which is the same as 5 to the first power. And because we cannot break down the 5 anymore, therefore we can just multiply this by the cube root of 5 to the second power and do the same thing on the top. On the bottom, we'll just get a regular 5. On the top, this is on the outside, this is on the inside. We cannot multiply them, just put them together. 6 cube root of 5 squared, which is 25. And then we are done. That's it for that. Now for the next one, we have 12. Yes, it's the same as 12 to the first power, but we can break down 12, and we shall do that too. So if you draw the factoring tree, 12 is the same as 3 times 4, and then the 4 is the same as 2 times 2. So we can look at this as 4 over the cube root of, let's put down the smaller base first, even though the order doesn't matter. 2 times 2, which is 2 squared, and then 3, which is the same as 3 to the first power. Now, for the 2, we have 2 powers already, so we need 1 more. So let's multiply by the cube root of 2 to the first power. And for the 3, we have 1 power only, we need 2 more. So multiply by 3 to the second power. And do the same thing on the top. Okay, on the top, I'm just going to have the 4 and then cube root of 3 squared, which is 9, times 2, which is 18. That's what we have. But for the bottom, we will just have 2 to the third power in the cube root, which is just a 2. 3 to the third power in a cube root, which is just a 3, which will get a 6. So that's what we have for now, but notice 4 and 6 can be reduced. So divided by 2, divided by 2, final answer 2 cube root of 18 over 3. And then we are done, just like that. Now, for this one, notice we have cube root of 2 over cube root of 18. You can break down 18 and all that, but guess what? Because the 2 is inside of the cube root, likewise the 18, when you divide, you can reduce the numbers first. So this is equal to the cube root of 2 over 18. And then we can reduce this. It will be 1 and 9. Now, if you do the cube root of 1, it's just 1. And then if you do the cube root of 9, well, that's cube root of 9, which is the same as 3 squared. We still have the radical on the bottom, right? But it's okay. Let's multiply this by cube root of 3 to the first power. That's how we can get the third power. So on the top it's the cube root of 3. On the bottom it's just going to be a regular 3. And then we are done. Just like this.